Hello and welcome to a new video about, about what? About a thing which was broken after the winter. So I'm not sure if you have already seen such things like that. These are water heater, electrical water heater. Here would be the input. So you put this on your tap. Water in, water out, and here you can adjust if it should be hot or cold. That's it. Inside there's a little heater. Here you see there's a heater inside, and this heater should warm the water when the water is running through. So far so good. This was installed in our garden, and now after the winter, it was broken because simply the water inside there was frozen and it destroyed this cap. You see, it's just ripped off, just exploded. This usually here is a plug with a seal which holding the water inside. The original plan of my mother, it was my mother's idea to install this, was that usually we have solar powered water, warm water there in the garden, because we want to save energy, of course. But some days, at cloudy days and so on, this is not working very well. So she thought this would be an adequate thing to use on cloudy days instead of the solar power. I was not really convinced, because what is written there? 3000 to 3600 watts at 220 to 240 volts. Usually we have 230 volts, so this thing is usually producing 3300 watts. With 3300 watts, this is heating the water which is running through. Let's think about what this means, what this implies. So, need a pen. Use this one. We know that the work which needs to be added to heat water is the warmth capacity of water multiplied by the mass multiplied by the temperature difference, delta theta. Okay? And this C of water, this warmth capacity, is 4.2 kilojoule by kilogram and Kelvin. So to heat 1 kilo water by 1 Kelvin or 1 degree Celsius, you need 4.2 kilojoule. That's it. So we have given a power. So the power we have is, and now it's not the mass, but the mass flow. How many kilo per second, right? This is how many work per second. So this is how many kilo per second. So it's the flow. The rest is the same. And now I've looked up a usual water flow of a already very water saving shower head, is around 8 liters per minute. It's already very, very water saving. So we have around 8 kilos per minute. So this is 8 divided by 60 kilo per second. This is our run, our flow, mass flow. This we know. So let's calculate how much temperature raise we can expect from this device. So delta theta equals the power P divided by, so we had 3.3 kilowatts divided by 4.2 kilojoule by kilogram and Kelvin multiplied by 8 divided by 60 kilogram per second. Kilo is away. Kilo. Gone. And this is actually kilojoule per second. So also this is away. What is left is Kelvin. Okay, unit is accurate. Let's see what the result of our calculation is. We have 3.3 divided by 4.2 multiplied 8 divided by 60, and we have 4.89 Kelvin. So the temperature raise of this device before and after with a really water saving head, with a really shower head, is around 6 Kelvin, 6 degrees Celsius. And if you have an incoming temperature of 12 degrees Celsius, which is the usual temperature out of the tap here, then you would end at 18 degrees Celsius. This is darn cold. This is not a hot shower. So this thing, I don't know. In my opinion, it's pretty useless. These are the facts. So anyway, I installed it, and of course it was not turning out great. And now it's broken. But this gives me the opportunity, if somebody is producing this device, maybe to heat up, I don't know, usually we use 36 and let's say 35. So from 29 degree already, maybe after the solar panel it would make sense. Preheated water. But in my opinion, it's useless. Just a waste of energy. Now it's broken, and I want to open it and see how the engineering inside is. All right? This is interesting now. If I'm producing now a device which is not useful, how much effort do I spend in engineering? And therefore I will start to open this now, and let's see what is inside. See here, we have this. Still a little water. This one here is just a clip, just mechanical plug that makes a sound. Now you hear the sound. This is nothing. This is just to make a sound. Just to make a sound. Let's see further. Probably that's a fuse there. Fuse reset button. Okay. We have a fuse. This yellow color is actually from me. The yellow color is from me because I painted the shower yellow. So, nothing. This is spectacular. This is temperature measurement and the display. I'm not sure. What is this measuring? The actual temperature or just the power? Wow. A lot of dirt. A lot of dirt. Pressure switch. It's a pressure switch. Interesting. It's a pressure switch. I think it's a pressure switch. But it's only turned on if we have a certain pressure inside. Looks like that way. No. Because what I'm really interested in is how is it solved, this change of water temperature. The secret must be in here somewhere. I think it's just a bypass. Or it's just throttling. The hotter you put it, the less water will run through. This is my guess. It looks that way. It's even mixing. Look, there is the mixer. Mixing valve. Hot. Mixture. Cold. Mixing valve. These are the connectors. Probably one is hot, one is cold, and one is the output. These are the middle there. This is the pressure switch, so this should come directly from the water tap. I must say, the engineering looks okay. I'm always surprised actually how well built or how much thought there is in every so electric devices. There are rules, regulations. This thing here, control, as usual, just. I think you can pull it out. No, cannot. Okay. still not. There's this bolt, this little bolt here. Nut, actually it's a nut. Nut. I'm always surprised how good, how many parts and inside and how much work you put into such products. It's actually, like I said, in my opinion, pretty darn useless. Now I should be able to get rid of the cable. Okay. That's the fuse. So this is, there's the fuse inside with this red reset button. Actually, I should be able to pull this off. Yes. And now, what is left? Still left is this switch of the pressure switch. This would be interesting now. Still, how this is solved. There's water inside. Actually, if I blow inside here, what is this? I think it was inside like that. I cannot see this. I think it was inside like that. These are little magnets. So magnetic coupling, and whee! It's pretty strong magnets, I must say. Huh? They are sealed so that they are not rusty. And here, when this is getting close, I can feel it pressing, and this is really able to switch this little switch. Let's hear. Eh? This is cool. This I like. Once we are getting close, probably I put it in the wrong way. Turn it over. Switch inside. Magnet. This is cool. This is a nice switch, a proximity switch. Coming close. Back. I'm not entirely sure what is measuring. But it's for sure not the pressure on the pressure side. Temperature. Here we have a temperature. That. Okay, what is this? That. This is probably some heat conductive material. This is a thermo element. Classical thermo element. And with this thing here is measuring. Let's get this out. Here we have a thermo element, and this thing is measuring the heat of the thermo element. And this is just power supply, so this must be a rectifier here, full bridge rectifier, and this is just a display. And what's this? This is a capacitor. No, for the rectifier probably. The rectifier. And this is the heat measurement. Going here. Alright. So this is how this looks like inside there. Get this up. Yeah. Overheat protection. This thing also with the heat conductive material. Overheat protection. See? There. It was inside there. So even overheat protection. This is good. Yeah. And now I will completely dismantle it. So I want to get out the heating element. It feels like I'm gonna hurt myself because it's not the proper tool. Schade! Cannot get inside. Cannot get this out. Don't have the proper tool to. Don't want to destroy it. Yeah, but actually we're done. See, these are the connectors of the heating element. Here was the fuse, the heat fuse. Here was the temperature probe. Here was the pressure switch. Yeah. A lot of things inside. I will get this out someday. Alright, that's it. Now we have seen what is inside such device. For this time, thank you very much for listening. Goodbye.